In October 1942, at a discrete airfield in Ohio, test pilot Bob Chilton settled into the cockpit of a P-51 Mustang.
Superficially, it appeared identical to the Mustangs he had flown countless times before a sleek, aerodynamic marvel that seemed to slice through the air even when stationary on the tarmac. However, beneath its distinctive cowling resided a profound secret, an engine that the British fervently believed would revolutionize aerial warfare. The Rolls-Royce Merlin. Chilton possessed extensive experience with the standard P-51. Powered by its American Allison engine, at lower altitudes, it was a formidable aircraft. Fast, highly maneuverable, and a joy to fly. Yet, above 15,000 feet, its performance suffered a dramatic decline, rendering it sluggish and vulnerable. The Allison engine's single-stage supercharger proved inadequate for sustaining power in the rarefied upper atmosphere. Chilton pushed the throttle forward. The Merlin engine ignited with a deep, resonant rumble that seemed to shake the very ground. A stark contrast to the Allison's sharper, more piercing whine. Like a steam locomotive gathering immense power, the Mustang surged down the runway and clawed its way into the sky. At 10,000 feet, Chilton leveled off, meticulously checking his instruments. All systems were nominal. At 15,000 feet, an altitude where the Allison would begin to gasp for air, the Merlin maintained its robust power. Then, at 20,000 feet, the engine's two-stage supercharger engaged, unleashing a surge of raw power that pressed Chilton firmly back into his seat. At 25,000 feet, he advanced the throttle to its stop. The Mustang accelerated like a projectile. 400 miles per hour. 410. 420. Airfield. This is Chilton, he radioed, his voice barely concealing a tremor of pure exhilaration. You won't believe this. Bob, what's your status? Chilton glanced at his altimeter. 28,000 feet. His airspeed indicator showed a remarkable 432 miles per hour. The fuel gauge still read half full. He responded quietly, almost to himself. This isn't the same airplane at all. This is something entirely different. Back on the ground, Chilton climbed out of the cockpit and strode purposefully towards the engineering team. His demand immediate. How soon can we initiate production? The chief engineer shook his head. That's the problem, Bob. We can't. What do you mean? You saw what it just did up there. The Merlin is a British engine, manufactured by Rolls-Royce in England. They're already operating at peak capacity, supplying engines for Spitfires, Hurricanes, and Lancaster bombers, with no spare capacity available for us. Chilton's disbelief was palpable. Are we to understand that we've identified the fighter capable of winning the war? Yet, we cannot produce it. Unless we find an alternative manufacturing solution for the Merlin, the engineer responded. Producing a telegram? There is a potential avenue. The Packard Motor Car Company in Detroit, which holds a license to produce a limited number of Merlin engines for the British. If you can persuade them to significantly increase production for American fighters, then proceed immediately, Chilton urged. The aircraft I just piloted represents the future, and every day's delay translates to more bomber crews perishing. The engineer nodded slowly. I'll make the call. Neither man could have fully comprehended that this seemingly straightforward solution scaling up. Merlin engine production would necessitate overcoming one of the war's most intricate engineering challenges, culminating in an engine pilots would affectionately dub the air locomotive. The Merlin engine's genesis was not as an instrument of war, but rather stemmed from a profound ambition for speed. In 1933, the legendary British luxury automobile manufacturer Rolls-Royce embarked on developing a new aircraft engine for the Royal Air Force. The objectives were clear: to be more powerful, more reliable, and perform superiorly at high altitudes than any engine before it. Chief Engineer Ernest Hives assembled a formidable team comprised of Britain's most brilliant aviation minds. Working in strict secrecy, they relentlessly tested and refined, pushing the boundaries of mechanical performance. The culmination of their efforts was the Rolls-Royce Merlin engine, a UB-12 liquid-cooled power plant that, in its inaugural iteration, generated 1,030 horsepower. However, the true innovation lay not merely in its power output, but in its revolutionary supercharger design. Most aircraft engines of that era employed single-stage essentially air compressors, designed to force more oxygen into the engine as the air thinned at altitude. However, single-stage designs encountered their operational limitations above 15,000 feet, proving incapable of compressing sufficient air to sustain engine power. The Merlin, by contrast, featured a sophisticated two-stage, two-speed supercharger system. The first stage compressed the air, and a second stage compressed it again, with an intricate control system automatically switching between high and low speeds based on altitude. This innovative design enabled the Merlin to maintain full power output at altitudes nearing 40,000 feet. "This isn't just an engine," Hives reportedly told his team. "It's a revolution." The Merlin engine first saw operational deployment in 1937. Powering the Hawker Hurricane fighter. This was rapidly followed by the Supermarine Spitfire in 1938, as World War II erupted in 1939. These Merlin-powered fighters constituted Britain's critical first line of defense. During the pivotal Battle of Britain in 1940, the Merlin's distinctive growl became an indelible symbol of survival. Its deep, thunderous roar, profoundly different from the shrill shriek of German engines, signified that the Royal Air Force was airborne, fighting buck, and refusing to yield. British civilians learned to instantly recognize its distinctive sound. Upon hearing it, they would instinctively gaze skyward, often erupting in cheers. German pilots, too, learned to identify it, and they learned to fear it. By 1941, however, Britain faced a severe crisis. Rolls-Royce was manufacturing Merlin engines at the absolute humanly attainable maximum. Yet production remained critically insufficient. The RAF desperately needed engines for its Spitfires, Hurricanes, Mosquitoes, and Lancaster bombers. Production capacity had been exhausted. There was simply no spare capacity. Across the Atlantic, Americans were also beginning to realize their own critical need for the Merlin. Air Marshal Charles Portal, addressing a meeting of Anglo-American military leaders in early 1941, articulated the predicament. "We face a critical challenge. The Merlin engine, undeniably the world's finest aircraft engine, cannot be produced in sufficient quantities." An American general leaned forward, proposing, "What if we could undertake their production for you?" Portal raised an eyebrow. "America possesses the industrial capacity, the requisite factories, and skilled labor. If you furnish us with the blueprints and the manufacturing license, we are confident in our ability to produce Merlin engines by the thousands." Portal considered the proposition carefully. Entrusting Britain's most advanced military technology to another nation, even an allied one, carried inherent risks. However, the alternative was considerably more dire. "There is one company with the potential to undertake this," Portal eventually conceded. "The Packard Motor Car Company. They are already licensed to produce a limited number of Merlin engines for us. If any entity can scale up this production, it is Packard." "Then go speak to Packard," the American general instructed. What remained largely unarticulated in that meeting was the monumental technical challenge awaiting them. For the Rolls-Royce, Merlin engine was more than merely a complex piece of machinery. It was quintessentially British in its design, incorporating British imperial measurements, bespoke British materials, and specific British manufacturing techniques. America would be tasked with recreating it from the ground up. Colonel Jesse Vincent arrived at the Packard Motor Car Company headquarters in Detroit, his briefcase filled with blueprints and a seemingly insurmountable challenge. "Gentlemen," he addressed the assembled Packard engineers, "the United States Army Air Forces requires you to commence immediate mass production of the world's most advanced aircraft engine." He opened the briefcase, spreading the Rolls-Royce Merlin engine blueprints across the conference table. Chief Engineer George Christopher picked up a drawing, scrutinizing it intently before looking up, a pained expression on his face. "Colonel, these specifications are entirely in metric units. I know our manufacturing standards are exclusively imperial inches, feet, pounds. Every machine tool in our facility is calibrated accordingly. Can these be converted?" Christopher looked at the blueprints again. "C'est compris. Over 6,000 individual drawings, thousands of distinct parts, and tens of thousands of measurements. Each and every one will require conversion from metric to imperial, subsequent verification, and then retooling. What is the estimated time frame for this? Months? A year, perhaps?" Colonel Vincent's expression hardened. We do not have a year. Bomber cruiser perishing over Germany now due to insufficient fighter escort. We require these engines within 6 months. Christopher appeared as if Vincent had tasked him with constructing a lunar rocket. Colonel, that timeline is impossible. I know. Do it anyway. Christopher surveyed his engineering team around the table. Their gazes met his, expressions ranging from grim determination to stark apprehension. Very well, Christopher finally conceded. But we will require extensive support. Direct access to Rolls-Royce engineers, sample parts for every component, and complete authority to adapt anything that does not conform to American manufacturing standards. You'll get it, Vincent promised. What ensued was one of the most demanding engineering endeavors of the war. Packard engineers worked around the clock, converting dimensions, redesigning components, and creating entirely new manufacturing processes. The challenges were relentless. British bolts were incompatible with American threads. British steel alloys exhibited different properties from American steel, and British tolerances were specified 0.02 of an inch. A single miscalculation could result in an engine failure at 25,000 feet, leading to the catastrophic loss of both aircraft and pilot. This bolt, one engineer explained, holding up a small piece of metal, is specified at 8.5 millimeters. Converted to imperial, that's 0.33 for 6 inches. But we don't make 0.33 for 6-inch bolts. We make 11/32 bolts, which is 0.3438 inches. A difference of 0.0092 inches. So, use the 11/32 one, another engineer suggested. No. The tolerances are too tight. That extra 0.0092 inches means the bolt won't seat correctly in the engine block. Under stress, it could shear. Engine failure. Pilot dead. Then what do? We make new bolts, custom ones, precisely 0.33 for 6 inches. We create new dies to produce them, and new quality control procedures to verify them. Extrapolate this singular problem across 10,000 distinct parts, and the sheer magnitude of the challenge becomes apparent. Yet, Packard persevered. They brought Rolls-Royce engineers from Britain for consultation. They constructed prototype engines, testing them to their breaking point. Learning from each failure, they established entirely new assembly lines, meticulously designed specifically for Merlin engine production. Then, slowly, painstakingly, and against formidable odds, success began to emerge. In August 1941, just shy of Colonel Vincent's seemingly impossible 6-month deadline, the first American-built Packard Merlin engine rolled off the assembly line. It was designated the Packard V1650. Engineers held their breath as it was mounted on a test stand. Fuel lines connected, and the start button pressed. The engine coughed once, then again, and then roared to life with that characteristic deep, thunderous sound. The air locomotive had arrived in America. By early 1943, Packard's Detroit factories were soon producing Merlin engines at a rate Rolls-Royce had never conceived. 400 a month, then 600, then 800. The plant operated 24 hours a day, 7 days a week. Workers, many of them women filling roles vacated by men drafted into service, worked in 3 shifts, assembling the complex engines with a precision that would impress even Swiss watchmakers. Rosie the Riveter was not just a propaganda poster. She was real. And she was building the engines that would win the war. Each individual part required manufacturing 2 tolerances measured in thousandths of an inch. Every engine underwent a rigorous process: assembly, initial testing, disassembly, comprehensive inspection, reassembly, and a final test, all prior to clearance for aircraft installation. Quality control was meticulous. Inspectors checked each component multiple times, and test runs extended for hours, pushing engines to their operational limits to identify any potential weaknesses before combat deployment. A faulty engine isn't just a failure. The head of quality control instructed his team. It's a failure at 30,000 feet over Germany, with a 20-year-old kid inside, who's counting on us to get him home safely. We don't ship anything that isn't perfect. The workers took this responsibility to heart. Stories circulated of inspectors rejecting entire batches of parts for minuscule, almost imperceptible flaws, of assemblers working unpaid overtime just to double-check their work. They understood the stakes. Meanwhile, at North American Aviation in California, engineers were preparing to install the Packard Merlin engine into the P-51 Mustang. This adaptation necessitated substantial modifications, encompassing new engine mounts, a redesigned cooling system, and an optimized propeller configuration. Yet, when the first production P-51B, powered by the Packard Merlin, rolled out in late 1943, test pilots confirmed Bob Chilton's findings from a year earlier. This was an entirely different aircraft. Its top speed at 25,000 feet soared to 437 miles per hour, and its service ceiling attained 41,900 feet. Equipped with external drop tanks, its operational range extended to an unprecedented 1,650 miles. For the first time in the conflict, the Allies possessed a fighter capable of escorting bombers deep into German territory, all the way to Berlin and back. "This changes everything," General Jimmy Doolittle declared after his first flight in a Merlin-powered Mustang. "The Germans won't know what hit them." He was correct. In December 1943, the first P-51B Mustangs arrived in England and were assigned to the 354th Fighter Group, dubbed the Pioneer Mustangs. Their mission, to escort B-17s and B-24s deep into Germany. On December 13th, the Mustangs undertook their inaugural long-range escort mission to Kiel, Germany. The Luftwaffe rose to meet them, anticipating that the American fighters would, as usual, turn back when their fuel ran low. But the Mustangs did not turn back. They stayed with the bombers all the way to their target. When German fighters attacked, the Mustangs pounced with a ferocity the Luftwaffe had never encountered. The P-51s were faster than the Bf-109s, more maneuverable than the FW-190s, and they possessed the range to pursue German fighters all the way back to their own airfields. "It's not fair," a captured German pilot reportedly complained. "Your fighters can do everything. How are we supposed to fight against such a thing?" The answer was, increasingly, they couldn't. By early 1944, P-51 Mustangs were arriving in Britain by the hundreds. Packard was producing Merlin engines faster than North American Aviation could build airframes. The Detroit factories had become the pulsating heart of American air power. Workers called the Merlin the air locomotive, not only for its deep, powerful growl, but because it pulled the entire Allied air campaign forward, much like a train pulling its carriages. Over Germany, Luftwaffe pilots began to dread that sound. The deep rumble of the Merlin meant the Mustangs were here, and when the Mustangs were here, German pilots died. The transformation was complete. The P-51 Mustang, once a fighter with potential but significant limitations, had evolved into the most lethal air superiority weapon of World War II. All thanks to an engine built by workers in Detroit, who understood that every bolt they tightened, every part they assembled, and every engine they tested was bringing American sons home alive. On March 6, 1944, over Berlin, Germany, Captain Don Gentile, piloting his P-51 Mustang, executed a sharp dive, its Packard Merlin engine howling as he closed in on a German Bf-109. This marked the first instance. American fighters had provided escort for bombers all the way to Berlin, the heart of Nazi Germany, a distance of 600 miles deemed impossible just 6 months prior. But with the Merlin engine and external drop tanks, the Mustangs had made it. And now they were hunting. Gentile's gun sight locked onto the Bf-109. He pressed the trigger. 6 .50 caliber machine guns roared. The German fighter disintegrated in a cloud of debris. "Splash one," Gentile reported calmly. Around him, the sky was a tapestry of contrails and tracer fire, as Mustangs and German fighters tangled in a massive aerial engagement. But the outcome was never in doubt. The P-51s were simply superior, faster, more agile, and flown by pilots who had trained for months for this moment. As the bombers completed their mission and turned for home, the 336th Squadron claimed 11 German fighters without losing a single Mustang. "How much fuel you got?" Gentile, his flight leader, called out. Gentle checked his gauge, enough to get home, with plenty to spare. "Then let's keep hunting on the way back." They did, finding more German fighters attempting to regroup. By the time the Mustangs returned to friendly airspace, Gentile had claimed for enemy aircraft for the day. The squadron claimed 17 in total. This mission proved a pivotal turning point. For the first time, American bombers struck Berlin with comprehensive fighter escort from takeoff to landing. The Luftwaffe committed all available resources to counter the raid, but was decisively decimated. The Krauts were scared. One bomber pilot recounted after landing. You could tell, when they heard the sound of the Merlin, they just scattered. They knew they couldn't win anymore. He was right. The strategic landscape had irrevocably shifted. Prior to the P-51, German fighters could engage American bombers with relative impunity, confident that escorts would eventually have to disengage. Now, escorts could remain throughout the entire mission. The Luftwaffe incurred unsustainable losses, effectively bleeding itself dry as German fighter losses skyrocketed. In a series of massive raids in February 1944, known as Big Week, the Luftwaffe lost over 500 fighters, and more importantly, many of its most experienced pilots, irreplaceable men, were not just shooting down their planes, General Doolittle explained to his staff. We're destroying their ability to train new pilots. Every ace we kill means 100 new recruits won't learn how to fight. We're breaking them. And the Mustang was the weapon that broke them. By D-Day, June 6, 1944, the Allies had achieved complete air superiority over Europe. German fighters were virtually absent over the Normandy beaches. The Luftwaffe had been so thoroughly battered in the preceding months that they were incapable of mounting an effective resistance. Where is the Luftwaffe? German soldiers on the ground bitterly questioned as Allied aircraft strafed them with impunity. The answer: shot down by Mustangs, destroyed on the ground by Mustangs, and hiding in fear of Mustangs. The P-51 Mustang was ultimately credited with destroying 4,150 enemy aircraft in the air, more than any other Allied fighter. Another 431 were destroyed on the ground during strafing attacks. The kill ratio was staggering. 19 German aircraft destroyed for every P-51 lost, and at the heart of every Mustang was a Packard Merlin engine, the air locomotive built by American workers in Detroit and shipped across the Atlantic, which ultimately helped win the war. Captain Chuck Yeager, who would later become the first man to break the sound barrier, flew the P-51 Mustang in combat over Europe. Years later, he described what it felt like to fly the Merlin-powered Mustang in battle. You'd be up at 30,000 feet, and you'd see German fighters below, Yeager recalled. You'd roll over, push the throttle forward, and that Merlin engine would just sing. That deep, powerful sound let you know you had all the power in the world. You'd dive down at 500 miles an hour, and the Mustang was rock solid, stable, responsive. You'd get on a German's tail, and they couldn't T-shake you, couldn't outrun you, couldn't get away from you. He was dead, and he knew it. And when you pressed the trigger and saw the tracers hit and watched him start smoking and go down, you didn't feel happy, but you felt satisfied, like you'd done your job, like you'd protected the bombers, like you'd brought your buddies home. Jägerpaul said, lost in the memory. The Mustang wasn't just a fighter. It was a weapon system. The airframe, the guns, the pilot, they were all good. But at its heart, the thing that made it work was that Merlin engine. Without the Merlin, the Mustang was just a good fighter. Good, but not great. With the Merlin, it was the best fighter in the world. And that's what made all the difference. The statistics unequivocally supported Yeager's assessment. The majority of America's top aces in Europe flew the P-51 Mustang, with Major George Preddy, the top ace, scoring 26.83 kills in the Mustang before his tragic death by friendly fire in December 1944. However, the Mustang's impact extended far beyond individual kills. It fundamentally shifted the strategic balance of air warfare. Before the P-51, the Allied bombing campaign was failing. Losses were unsustainable. Targets weren't being destroyed, and the Luftwaffe was winning. After the P-51, the bombing campaign became unstoppable. German industry was systematically destroyed. Oil refineries, ball-bearing factories, aircraft manufacturing plants, all reduced to rubble. And the Luftwaffe couldn't stop it, because they were too busy struggling for survival against the relentless pursuit of the Mustangs. The P-51 Mustang was the most important airplane of World War II, historian Stephen Ambrose wrote, not just because it was the best fighter, which it was, but because it made strategic bombing possible, and strategic bombing destroyed Germany's ability to wage war. At the core of this monumental achievement was an engine designed by British engineers, built by American workers, and installed in the American fighter that became legendary. The air locomotive had pulled the Allies towards victory. By the end of World War II in 1945, Packard had produced an astonishing 55,523 Merlin engines. Each one was a masterpiece of precision engineering, built to tolerances considered unattainable just a few years prior. The workers who built them, many of whom had never worked in a factory before the war, had become the most skilled manufacturing technicians in the world. They had transformed British blueprints, written in foreign measurements, into a triumph of American industry. We weren't just building engines, one Packard worker recalled years later. We were building hope. Every engine that left our factory meant another pilot had a chance to come home. Another bomber crew was protected, another mission could fly. We worked 12 hours a day, 6 days a week. Our hands were always dirty. Our backs always ached. But we never complained because we knew what we were building mattered. The impact of their labor was quantitatively measurable. In 1943, before the widespread deployment of the P-51 Mustang, the 8th Air Force lost an average of 176 bombers per month. By late 1944, with Mustang escorts in force, that number plummeted to 40 per month, a reduction of 77%. Each bomber carried 10 crewmen. This meant that the Mustang and its Merlin engine saved approximately 1,600 American lives per month during the war. This adds up to tens of thousands of individuals who made it home because a Packard worker in Detroit tightened a bolt correctly, or an inspector caught a flaw, or an engineer solved an impossible problem. The Merlin engine also powered other legendary aircraft. The Avro Lancaster, which brought the war to Germany's cities, the de Havilland Mosquito, the fastest bomber of World War II, and the British Spitfire that saved Britain in the Battle of Britain. But it was in the P-51 Mustang that the Merlin engine found its greatest fame. The synergy of North American aviation's superb airframe design with Rolls-Royce's revolutionary engine, mass-produced by Packard, created a whole that was far greater than the sum of its parts. It created a weapon that changed history. After the war, many P-51 Mustangs were sold as surplus. Some went to foreign air forces. Some were purchased by civilians and converted into racing planes. A select few were meticulously preserved in museums and at air shows across America. When a restored P-51 Mustang fires up its Packard Merlin engine, crowds still gather to hear that sound, that deep, thunderous growl. It was the sound that once meant salvation for a bomber cruise over Germany. It was the sound that once meant death for Luftwaffe pilots. It was the sound of the air locomotive. In 2024, fewer than 200 P-51 Mustangs remain airworthy worldwide. Each is a treasured artifact, maintained by dedicated volunteers and aviation enthusiasts who deeply understand the historical significance of these machines. At the National Museum of the U.S. Air Force in Dayton, Ohio, AP-51D Mustang stands in a place of honor. A plaque beside it recounts the aircraft's combat record. 47 missions, 3 aerial victories, 0 losses. But next to it, another plaque tells a different story. The story of the Packard Merlin engine. This engine, the plaque reads, represents one of the greatest industrial accomplishments of World War II. It combined British engineering genius with American manufacturing capability to create the power plant that brought the Allies' air superiority and helped win the war. Visitors pause to read the plaque. Some take photographs. A few, often older men, who are veterans themselves, stand silently for a moment, lost in reflection. An elderly former B-17 pilot gently touched the Mustang's propeller. "This plane saved my life," he softly told his grandson. "I was on missions over Germany in 1944. We lost so many planes, so many friends. Every mission felt like a death sentence. Then the Mustangs showed up. Suddenly, we had a chance. When you heard that sound, the deep growl of the Merlin, you knew you'd be okay. The Mustangs were there. They would protect you." His grandson looked up at the sleek fighter. "It's beautiful." "It was more than beautiful," the old pilot said. "It's why I'm standing here today. Why I gotta come home, get married, have your father, and meet you. All thanks to this plane, and the engine that powered it." He paused, his hands still on the propeller. People talk about the greatest generation, about the sacrifices we made. But I think about the men and women who built this engine. Those workers in Detroit who never fired a shot, never flew a mission, never saw combat. But they, as surely as any pilot or soldier, won the war. Every bolt they tightened, every part they assembled, every engine they tested, was saving lives. My life. And they did it with a precision and dedication that still amazes me. His grandson nodded, beginning to comprehend. The air locomotive, the old pilot read from the plaque. That's what they called it. It pulled us all the way to victory. The story of the Packard Merlin engine transcends a mere tale of technology. It stands as a testament to the synergistic power of engineering excellence and industrial resolve. The Rolls-Royce Merlin was a masterpiece of British design, a revolutionary engine that advanced the frontiers of mechanical performance. Yet, Britain alone could not meet the demands for Merlins required by a global war. The Packard Motor Car Company undertook this British masterpiece and achieved an equally remarkable feat. They engineered its mass production. They meticulously converted 6,000 metric blueprints into imperial units, forged entirely new manufacturing processes, and trained workers, many of whom had no prior factory experience, to work to tolerances of thousandths of an inch. They accomplished this feat within 6 months, a timeline deemed impossible. The culmination was 55,523 engines, powering the aircraft that secured air supremacy in Europe. These engines were so reliable, so exquisitely engineered, that many continue to operate today, 80 years later. The Merlin engine represented the quintessential Anglo-American engineering partnership. Aviation historian Barrett Tillman wrote, "British innovation met American production. British precision met American scale. Together, they created something neither nation could have achieved alone. The P-51 Mustang, powered by the Packard Merlin, became the symbol of Allied air superiority. It was faster than German fighters. It had greater range. It was more reliable. And there were so many of them, a relentless tide of silver fighters that swarmed the skies of Europe, grinding the Luftwaffe to dust. German pilots called them the plague. They learned to fear the sight of a Mustang and the sound of its Merlin engine. That deep, powerful growl was the herald of death. But for Allied pilots and bomber crews, that sound meant something entirely different. It meant protection eat Mantobe. It meant they had a chance to complete their mission and return home alive. When you heard the sound of the Merlin, one B-17 pilot wrote in his diary, you knew you were going to make it. The Mustangs were there, and nothing was going to touch you. The air locomotive truly lived up to its name. Just as the steam locomotive revolutionized transportation in the 19th century, the Merlin engine revolutionized air warfare in the 20th. It was powerful, reliable, and produced in overwhelming numbers that simply overwhelmed the enemy. It changed the course of history. Today, when a restored P-51 Mustang takes to the sky at an air show, something magical occurs. As the pilot starts the engine, and the Merlin coughs once, then again, before roaring to life with that unmistakable sound, the crowd falls silent. Children point and gaze. Adults pull out their phones to record. Veterans stand at attention, tears in their eyes. In that moment, history comes alive. The Mustang taxis onto the runway. The Merlin's exhaust stacks glow cherry red. The pilot pushes the throttle forward, and the fighter accelerates down the strip with an earth-shaking roar. Takeoff. Liftoff. The Mustang climbs steeply, the Merlin pulling it skyward with effortless power. Then the pilot rolls it inverted. 10 pulls up. The Mustang's elliptical wings glint in the sunlight, and it shrieks past the crowd at 400 miles an hour. The sound is overwhelming. Not the shrill shriek of a jet engine, but a deep, visceral roar you feel in your chest. It's the sound of 12 cylinders firing in perfect synchronization. It's the sound of 1,490 horsepower unleashed. It's the sound of the air locomotive. That sound, an old man tells his wife, that's the sound of freedom. That's what saved us. That's what won the war. He is correct. The Packard Merlin engine, built by American workers in Detroit, designed by British engineers in Derby, and installed in American fighters in California, was one of the decisive weapons of World War II. It delivered air superiority to the Allies. It protected bomber crews. It destroyed the Luftwaffe. It helped end the war. But more profoundly, it represented something fundamental about the Allied victory. The power of industrial collaboration, the brilliance of engineering, and the sheer determination of ordinary people to achieve extraordinary things. The workers who built the Merlin engines in Detroit were not soldiers. They were not pilots. They were not heroes in the traditional sense. But they, as surely as any fighter or bomber crew, won the war. They did it with precision, with dedication, and with an understanding that every engine they built was bringing someone's son, someone's husband, someone's father, home alive. This is the true story of the air locomotive. It was more than just an engine. It was a symbol of what free peoples can accomplish when they work together toward a common goal. The Merlin engine powered the aircraft that won the air war, but it was built by the people who won the peace. The workers, the engineers, and the visionaries who understood that victory required not just courage on the battlefield, but excellence in the factory. Today, when you hear that deep, thunderous growl of a Merlin engine, whether at an air show, in a museum, or in a documentary, remember what it represents. It is the sound of innovation overcoming adversity, of collaboration triumphing over division, and of ordinary people achieving the extraordinary. It is the sound of the air locomotive.